All right. And also for future tests, I'm gonna start giving tests where you're allowed 2 hours to do it, so that way you have time to double check your answer. Because from future, I'm not gonna be going over looking over the decimal value to make sure you got it correct. So you do want to make sure that you look over that. So I'm gonna start giving you 2 hours for tests, so that way, well, you have enough time to double check your answer, and hopefully we start getting some better grade for test number 3. But usually test number 3 is a lot easier than test number 2. Any questions so far before we actually get started with chapter number 7? Yeah, the tests have been officially graded. So by the end of today, I'll unlock all of the correct answers so that way you can see what you did wrong on the test or also what you did right on the test. And also, if you finish the quiz after 7 p.m., there is no penalty for it. Like, as long as you start it off before 7 p.m., like, there is no penalty for it. All right. Any other question before I get started with today's class? And also just remember, especially like for today quiz, you just kind of just look at your notes, see when do we make our A value positive, when do we make our A value, when could it be negative or positive? Because some of you did mess up on that, on when to put the negative or when is the answer always positive. Anytime we're doing an in between, the A variable should always be a positive variable. The only time A should be, well, could be negative if it says Z is less than A or if it says Z is greater than A. But if it says negative A is less than Z, which is less than A, that A should always be positive. So just look at those things. So let's go ahead and let's start going over the notes. All right. So if you understood yesterday's notes, well, today's notes should be pretty similar. Cool. So today's notes, what we're gonna get started off with is we're gonna start doing a normal distribution. So we're not gonna be working with a standard normal distribution. We're gonna be doing a normal distribution. So the only thing different between a standard normal distribution, which this one is, and this is a normal distribution. So the only difference between a standard normal distribution and a normal distribution, if you look at the mean and the standard deviation for the blue normal distribution or standard normal distribution, if you look at it, it says mu is equal to 0 and sigma is equal to 1. When we have a normal distribution mean it could be anything other than 0 and 1. So if you look at this case, we have mu is equal to 1. We have sigma is equal to 0.5. So in this one, what we're gonna do, we're gonna get started where we're gonna start doing the application of it. Because before we just find the probability of the Z value. But today what we're gonna do, we're gonna be doing application. So application means we're gonna have word problem to do. So let's show you what we're gonna do now. But any question between the difference between a standard normal distribution and a normal distribution? All right, sweet. So when we're doing normal distribution, what you want to do, you want to draw a normal curve and shade the desired area. Once you draw the desired curve, what you want to go ahead and do is now convert the x value, convert the x value and convert it to a z value. Because if you remember, when you convert an x value to a z-score, you're standardizing the data set. So once I find this z-score, now my mu is equal to 0 and my sigma is equal to 1. So that's what you want to go ahead and do. So you first want to find the normal distribution. What you want to go ahead and do, take the z-score. Once you find the z-score, you're going to find mu is equal to 0 and sigma is equal to 1 because we standardize the data set. And then lastly, what you want to go ahead and do is step 3, find the area under the standard normal curve. All right, so let's go ahead and do this problem. So for this one, says example on how to convert the x value to a probability. So for this one, says find the probability for the following parts. So what we want to do, we want to find the probability that x is greater than or equal to 37. So for this one, what's my x value? Yeah, so x is equal to 37. Good job. What's my mu? So remember, I still haven't found the z-score. Yeah, there you go, 35. Lastly, what's my standard deviation? All right, everybody go with that? All right, everybody's good with that. All right, so if you look in the drawing, I already have my normal distribution. So I have 35 in the middle, because 35 is our mean. So then we're going to put right here 37. All right. So for this one, now to see which side to shade, what I have to do, I have to look at the inequality. So if you look at the inequality that I have here is this one. So kind of like an easy way to think about this, the inequality, whatever side it's pointing at, that's the side that you shade. If you're not understanding the less than or greater than, you just look at the inequality, look at which side is it pointing at. If it's pointing to the left, you shade the left side. If it's pointing to the right, you shade the right side. So which side is the inequality pointing at? Right. So we shade the right-hand side. All right. Everybody get how I shaded the right-hand side? All right. So now what we're gonna do, we're gonna standardize the data set. So remember, when we standardize the data set, that means we're gonna find the z-score. So we're gonna say z is equal to x, which is 37, minus mu, which is 35, divided by 5. So if you look at this, this is pretty much a review of what we did for chapter 3. Because if you remember for chapter 3, we were finding the z-score. So we're going to see the relative standing for this one. All right, so if I do 37 minus 35 divided by 5, what's my z-score? Let's try that again. So remember, 37 minus 35 divided by 8. Oh, there we go. All right, so let me go over how to do this on the calculator. I got a couple of different answers. So let's make sure you know how to do this. No, it should be by 5. All right, so let's do this. All right, so you want to do 37 minus 35 You get 2 divided by 5, then you get 0.4. Or if you want to do it all in one turn, you want to use parentheses. So you go parentheses, 37 minus 35, and then divide this by 5. Go. So you get 0.4. So 0.4 is our z-score. All right. Everybody get how I got 0.4? All right, so one thing you have to know, once you get the z-score is equal to 0.4, we standardize the data set. So now that I standardize the data set, now my mu is equal to 0. Now my sigma is equal to 1. So kind of notice, we first start off with this data set. We first start off with that x is equal to 37. We start off with mu is equal to 35 and sigma is equal to 5. But then once we standardize the data set, this is what you're left with now. So we're left with z is equal to 0.4. We're left with mu is equal to 0. And we're left with sigma is equal to 1. So for this one, we're going to find what is the probability that z is greater than or equal to 0.4. So kind of notice the difference between this and this. So if you kind of notice when we say probability x is greater than or equal to 37, that's pre-z-score. So this is before we take the z-score. But now that I took the z-score, now we want to write it like this. Because now we're saying we found the z-score, and the z-score for this will be 0.4, and we want it to be greater than 0.4. Everybody kind of okay with that so far? All right. So let me put 0.4 here. So 0.4, go right here. Okay, just remember we converted 37 and we converted that 37 into 0.4. So that way on the top I put 0.4. All right, so once I find the z-score, how can I convert the 0.4 into a probability? Which function should I use in my calculator? Start with an n. Remember, start with an n. N-O. That still doesn't start with an N. Yeah, normal CDF. So we do normal CDF. All right. So for this one, what's my lower bound? And remember, we're looking at the z-score. We're not looking at the x. So what's my lower bound? What's the lowest number that I shaded in the red? Point. Remember, in the red, but the z-score, 0.4. What's the highest number that I shaded in the red? Or does it keep going, going perfect, infinity? So it's 10 to the 10 power. All right, what's my mu? Good. What's my sigma? Good. All right. So if you look at this one, once we find the z-score, you want to be using the z value. You're not going to look at the x value anymore, because that's why you found the z-score, to be able to convert it more easily, to convert it easier on your calculator. All right. So any question on how I got normal CDF of 0.4, comma 10 to the 10 power, comma 0, comma 1? All right then. So let me go to the TI-84. All right, so let's turn it on. So remember, for the TI-84, you hit the second button. you have VARS, and we go right here where it says normal CDF. So for the lower bound, we said it was 0.4. My upper bound was 10 to the 10 power. And lastly, for mu is 0, sigma is equal to 1. And you go to paste, you go to enter, and we get point. So we get probability that Z is greater than or equal to 0.4 is equal to, if you look at it, if you want 4 decimal places, so we get 0.3, 4, 4, 5, 7. All right. So if you look at it, I wrote 5 decimal places because I'm going to use the 5th decimal place in order to round my 4th decimal place. So if you look at it, you're using this 7 to round up this 5. So since 7 is bigger or equal to 5, that means you round up the value to the left of it up. So that means your final answer should be 0.34446. All right. And that's how you do it when you have a normal distribution. So for a normal distribution, what you could always do, you get the X value, you convert it into a Z-score. Once you convert it to a Z-score, the mean and standard deviation become 0 for the mean, 1 for the standard deviation, and then you just do normal CDF of that Z-score. And that's it for that. All right. Any question in regard to that first problem? All right, so let's go over to the second question. So let's do B. So for B, if you look at it, it says probability that X is greater than 37. Well, for this one, you should already know the answer. What's the answer for this one? Cool. Thanks, Javier. So the answer should be 0.3446. If you look at A, if you look at B, there is no difference between A and B. The only thing different is you have an equal sign, but when you're dealing with continuous data set, the equal sign is meaningless to it. It doesn't matter if I include the 37 or if I don't include the 37, the answer should still remain the same. It should still be 0.3446. All right. But that's not why we're going to do it. So for this one, there is a way in your calculator to get the answer without converting it into a Z-score. So let's do that. So I'm going to go ahead and draw it out. There you go, 37. If you look at this inequality, it's still pointing to the right-hand side. So you still want to shade the right side. All right, so let's do this problem. So for this problem, what we're going to do, we're going to find the probability of this X value without converting it into a Z-score. So this is without converting it to a Z-score. So for this one, what's the lowest value that I shaded in red for this problem? Oh, 37, there we go. What's the highest value that I shaded in red, theoretically? There we go, 10 to the 10 power, perfect. All right, so for this one, you have to be careful because for this one, I did not convert it into a Z-score. So for this one, what is my mean? 35. So we leave it as the original mean. What's my standard deviation? Perfect. So we get 37 is my lower bound, we get 10 to the 10 power is my upper bound, and we get 35 is our mean, and we get 5 is our standard deviation. So for this one, since we didn't take the z-score, we didn't standardize it. So since we didn't standardize it, that means the mean is not 0 and the standard deviation is not 1. So let's go over to our TI-84 or 83 or whichever one you have. And let's calculate this. Let's see if we get the same answer. All right, so if you look right above, that's the answer I got using the z-score. So now we're going to find the answer just using the normal distribution or the x value. So for lower bound, we put 37. Upper bound, still 10 to the 10 power. Our mean, we had to change our mean to 35. We had to change our sigma to 5. We go to pace. You go to, so if you look right here, I have 37, comma, 10 to the 10 power, comma, 35, comma, 5. So you press enter. Cool. And if you look at it, we get exactly the same answer. So that's why it's important that you know the difference between a standard normal distribution and a normal distribution. A standard normal distribution means that you have the z-score because you standardize the data set. So the mean should be 0 and the standard deviation should be 1. If you have a normal distribution means that the mean and the sigma is not 0 and 1, is something else. So you do have to adjust it in your normal CDF. All right. Any question in regard to that? All right. All right, so let's go ahead and do this one. So if you look at this one, it says C, it says probably that X is less than 24. All right, so let's go 24. So 24 is somewhere over here. Let me put 24 over here. Which side of 24 should I shade? Should I shade the left side or should I shade the right side? Left or right? Cool. So you shade the left side because if you look at the arrow is pointing to the left-hand side. So we say left. All right, so if you look at what I shaded, I didn't shade that much. So that should kind of tell you like our probability should be pretty low. So let's go ahead and do our normal distribution. Or normal CDF, sorry. All right, so for this one, which should be my lower bound? Cool. Yeah, so for this one, you're gonna put negative infinity. Anytime it goes all the way to the left-hand side, you're always gonna put negative infinity. So we put negative 10 to the 10 power. All right, what about for my upper bound? What's my upper bound? Oh, 24. What's my mean? Wait, 35. What's my standard deviation? All right, so let's see what answer do I get. All right, so for this, I'm gonna do it in my calculator. So we do normal CDF negative 10 to the 10 power. And just remember, you want to use the negative below the 3, not the negative below the multiplication sign. Because the negative below the multiplication sign will give you the wrong answer. Or it will give you a syntax error. All right. So once you punch that into the calculator, what do you get for an answer? Cool. So you get 0.0139. All right, so that's what you should get for your answer. So 0.0139. And that's it for C. Any question in regard to C? All right, so what I want you to do, I want you to practice on D, and I also want you to practice on E. E really shouldn't take you that long at a time. Like you don't even need a calculator to do E. So do D and do E. And if you wanted me to double check your answer, yes, either put it on the chat room or put private message and I'll let you know if you got it correct or if you don't need a little bit more training to do or practicing. All right, so far we got 2 people giving me the answer and both of them were correct. So 100%. Anybody else? So this is the time you really want to practice because like for the test, there is no practice. It's pretty much you either get correct or you get it wrong. All right. All right, so let's try to do here. So most of everybody got it correct. So let's do D. So if you look at D, it's at 33.7. So that's 33.7. Or I'm gonna say that's 33.7. I'm 100% sure it's not exactly 33.7, but it's close enough. So first you wanna look at the inequality. And all you wanna go ahead and do pretty much is use the inequality to figure out which side of the 33.7 should I shade. So if you look at it, it's pointing to the right side, so you shade the right-hand side. Right. So if you are having trouble like figuring out what's the lower bound, what's the upper bound, Like the easiest way to look at it, so look at the graph or look at what you shaded. The lowest value that you shaded or the left side that you shaded will always be the lower bound. So if you look at this one, the left side that I shaded will be here. If you look at the right side, it will be here. So always look at what you shaded, and pretty much whatever you shaded that is on the left side, the lowest value on the left side will be the lower bound. Whatever you shade on the right side, the highest value that you shade on the right side will be your upper bound. So if you look at this one, the lower bound, it had the cutoff, but if you look at the upper bound, it doesn't have a cutoff. It keeps on going and going to the right-hand side. So that means for the upper bound, it's going to positive infinity. So if I do normal CDF, you should get 33.7 for my lower bound, because if you look at the lower bound, it gets cut off at 33.7. If you look at the upper bound, it keeps going to the right-hand side, so that means positive infinity, which is 10 to the 10th power. The mean is 35, sigma is 5, so on and so forth. All right, everybody good so far how I got those values? All right, so if I do probably x is greater than 33.7, you get probably that x is greater than 33.7. That's going to equal to 0.6026. And that's it for D. Any question in regard to D? All right, so let's do E. So for E, if you look at it, it says 35 and it says less than 35. All right, so hopefully for this one, you don't need a calculator to do that, because if you look at it, I essentially cut it in half. Since I cut it in half, well, that means 50%. And for this one, if I ask you to round it to 4 decimal places, well, essentially you can't really round it to 4 decimal places. You just put 0.5. Right. But like for your, well, not for your test, but for your homework, start practicing just rounding percentages off to 4 decimal places. And also just know, like, when can you get a negative value? When can you get a positive value? If you're finding the probability of something, like the answer should never, ever, ever, ever be negative. It should always be a number between 0 or 1. So you should kind of already be training your mind saying like, okay, if I get a probability that's negative, something's not right, because you can't get a probability that's negative. All right, but all right, so those are your 2 practice problems. Any question for those practice problems? All right, so these are like your baby problems. So let's actually get to a real problem. Let's see what the score. All right. So for this one says IQ score can be modeled by a normal distribution with mean equal to 100 and standard deviation equal to 15. Find the probability of an individual having an IQ score of 120. All right. So if you look right here, I already did the mean for you. Here is the mean. So the mean is 100. If you look at my standard deviation, what is standard deviation equal to? Oh, 15, perfect. All right, so if you look at this one, it's saying find the probability of an individual having an IQ score greater than 120. So if you look at 120, 120 is somewhere over here, or somewhere close to that. All right, I think I lost connection, so let me just stop sharing and then we'll reshare right now. So that way you could be able to see what am I doing. All right, so there's 120. All right, so right here, there is no inequality I'm giving you, so you can't just use the thing saying if it's pointing to the right, you shade to the right, or if it's pointing to the left, you shade to the left. For this one, it says greater than 120. So if you look at my number line, I want it to be greater than 120. So where do I have numbers that are greater than 120? On the left-hand side or on the right-hand side? Wait, so you have the right-hand side. So that means we're gonna say the right side. Any question why we shaded off the right-hand side? Okay, so let's do our lower bound and the upper bound. So the lower bound, just put the lower bound at the lowest value that got shaded. So what's the lowest value that gets shaded? Yeah, 120. So put lower bound here. And if you look right here, we'll put upper bound. Cool. So if you look at my upper bound doesn't have a cutoff. It keeps going and going and going and going to the right hand side. So we're saying normal C, D, F. So for this one, what should I put for my lower bound? Perfect, 120. All right, what should I put for my upper bound? All right, so for this one quick question. Does it make sense for somebody to have their IQ score to be infinity? No, but do we know like where should we cut it off? Like, do we know like, hey, should we cut it off at like IQ score 200 or IQ score 300? Like, you really don't know when to cut it off. So even though it doesn't make sense that their IQ score could be infinity, we just put it to infinity just because we don't really know where should we cut off the upper bound. So sometimes you're gonna have to put like negative infinity, and you go like, how can somebody have a negative infinity IQ score? And we just put that because we just go like, we don't know where to cut it off. So we're gonna say it's negative infinity or positive infinity. So there are gonna be some occasions where it doesn't really make sense to put negative infinity or positive infinity, but you just put it because like we don't know where the natural cutoff will be. Yeah, like we don't want negative infinity IQ score. All right, what's my mean? Oh, 100. What's my standard deviation? Wait. All right. So what I'm gonna go ahead and do, I'm gonna go ahead and go back to my calculator, and we're gonna work this out, and we're gonna be done. So we're gonna go second bars. We're gonna say normal CDF. So we're gonna put 120 because that's the lower bound. Oops, I put 120. You go upper bound. Upper bound is 10 to the 10 power, so that's good for me. My mean is 100. My standard deviation is 15. We go here to paste, go to enter, and if you look at that, we get 0.0912. All right, and that's it for that problem. Any question in regard to how I did this problem? All right. All right. So if I were you, I would start putting like notes on like when do I use a normal CDF? Because if you look at this one, we have two different occasions when to use a normal CDF. We have the normal CDF when we're looking for when we have z-score, and we're trying to find the probability of that z-score, but we also are doing normal CDF when we have an x value. So you do kind of want to put a list on when do we use the normal CDF. All right, so let's do a follow-up question. So the follow-up question asks, if 100 individuals are randomly selected, how many should we expect to have an IQ score greater than 120? So how many individuals do I have in this random selection? Cool. So we have 100 people. So let's say individuals. Cool. So I have 100 individuals. So if you look at the probability, cool. Yeah. Mostly everybody getting this. Perfect. So if you look at it, it's telling me 9% of people have an IQ score higher than 120. So what the 9% telling me is telling me, hey, if I have 100 people well, not in the class, like I don't want to be in that class. If I have 100 people, of those 100 people, approximately only 9 of them should have an IQ score of 120 or greater. So to get that, you do 100 times 0.0912. So that gives you 9.12. So for this one, we should say, we should expect 9 individuals All right. Yeah, like if it was 9.5, you could just round it up to a full human being. But remember, the expectation doesn't mean it's always going to be 9. It might be a little bit higher than 9. It might be a little bit lower than 9, but that's what we should expect. Correct. All right. But that's it for that one. Any question in regard to the last one? All right, so let's do this next problem. So for this next problem, kind of took away everything away from you. So for this one said, a lifetime of certain brand of tire is approximately normally distributed with a mean of 42,500 miles with a standard deviation of 3,200 miles. So if you notice for this problem, I didn't tell you mu, oops, is equal to blah, 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 and I don't tell you sigma is equal to blah, blah, blah. In this one, what you have to do, you have to read the problem and see based off of the word given to you, like what's the mean and what's the standard deviation. So for this one, what do I tell you the mean is equal to? Yeah, so you go 42,500. If you look at sigma, what is sigma is equal to? Oh, great job. So if you look at this problem, you actually have to read the problem, look for the where it says mean, look where it says standard deviation, in order to find what the mean of standard deviation is. All right, so if you look right here, the mean go in the middle, so you put 42,500 in the middle. So remember, the mean always go in the middle. So for part A, it says, if we randomly select one tire, what is the probability that the tire lasts over 45,000 miles? So just remember this right here, that's the number line. That's the number line that go from lowest to highest. So if we want to put 45,000, 45,000 should fall somewhere over here to the right side. So 45,000 should fall somewhere on the right side because 45,000 is bigger than 42,500. All right, so for this one, which side of 45,000 should I say? Should I say the left side 45,000 or the right side 45,000? All right, so right now we have left, right. Um, all right, pretty much the right. We have 1, 2, 3, 4, 5, 6, 7. 7 with right, 1 with left. So the winner is right. Because if you look right here, it says last over. Last over means it has to be greater than 45,000. So since we want it to last over, you're going to shade the right-hand side. All right, so if you look at this, that means this is my lower bound. This is my upper bound. So just remember, like for this one, like if you saw like how we start off the class and not how we're doing it, you're gonna have to be able to read these problems to be able to decipher like which side to shade. So you have to look at if it says like greater than, more than, or last over. That's kind of telling you want to shade the right hand side. But if it says less than, smaller than, below than, like this is telling you to shade the left hand side. So you do kind of want to look at these words and see like, is it telling me to shade the left side or is it telling me to shade the right side? All right, everybody good on so far my drawing? All right, so let's go ahead and do a normal distribution CDF. So let's say normal CDF. So for this one, what should I put for my lower bound? All right, so we got 1, 2, 3. All right, cool. We have 4 people. So we got 45,000. What should I put for my upper bound? So also just remember, it doesn't really make sense that a tire will last infinite many miles. But since we don't really know where to cut it off, you go with it and you put 10 to the 10 power. All right, so if you look at it, now we want to put the mean. So the mean is 42,500. My standard deviation is 3,200. All right, let me do a little bit of cleaning up here. All right, like this. All right, so that's how you want to enter into your calculator. So you put 45,000. So also in the calculator, do not put a comma in between 45 and 000. The calculator will get extremely confused if you do that. So don't put the comma. So you put 45,000 and then 10 to the 10 power and then 42,500 and then 3,200. And what do we get? Cool. All right, so we got one answer, two answers. So I'm pretty sure that answer is correct. All right, sweet. Everybody got. So the way you will write this as an inequality, we'll say probability of x is greater than 45,000 is equal to 0.2173. And that's your final answer. So if you notice right here, I put the x value because we didn't convert it into a z-score. If I would have converted to a z-score, you replace the x with a z, and then whatever the z value is. But since we didn't even bother to find the z-score because it's kind of useless, like we leave at probably that x is greater than 45,000 miles. Any question in regard to A? All right, let's go ahead and let's do B. Oh, geez. Let me get myself in this. All right, so we still know is 42,500. So if you look at this one, said if we randomly select one tire, what is the probability that the tire lasts under 37,675 miles? So we want it to last under that. So we'll put it over here. Let's see if I could jam that in. So 37,675. All right. So for this one, since we want it to last under 37,675, which side of the 37,675 should I say? Left or right? Cool. A barrage of left. All right. So now if you look at this, my lower bound is on the left side. My upper bound is over here. Because the highest value that gets shaded is 37,675. The lowest value that gets shaded is negative infinity. Also remember, it doesn't really make sense logically of a tire having negative infinity miles, but just because we don't really know where to cut it off, where you're gonna go with it instead that it goes to negative infinity. But in the real world, you would go like, obviously a tire cannot be negative infinity miles. All right, so let's go ahead and do normal CDF. So for normal CDF, you want to put the lower bound. So the lower bound for this one will be what? Negative 10 to the 10 power. Cool, somebody already gave me the whole thing. Perfect. 675, 42,500, and we go 3,200. Perfect. All right, so if I wanted to write this as probably the X, you put less than 37,675. Also remember, it doesn't matter if you put an equal sign, you should still get the same answer. All right, so two people have the same answer, so that seemed pretty correct if two people have the same answer. All right, so if you look at this one, this is telling us roughly 6% of the tire lasts under 37,675. So kind of think about it, if you have a batch of 100 tire, like of those 100 tire, 6 of them is gonna last less than 37,675. If you look at how many of those 100 tire will last more than 45,000, well, you have roughly 21 of them that will last roughly higher than 45,000 miles. Because just because they were produced in the same place doesn't necessarily mean they will all get the same value. Like some will last longer, some will last shorter. Kind of depend on the draw. All right, but any question in regard to the second part? All right, sweet. All right, so let's do this next problem. So something like this will not be on the test, but it's actually a fun problem and it actually makes you think. So let's do this next problem. So it says a machine that cut cork for a wine bottle operates in such a way that the distribution of the diameter of the cork produced is well approximated by a normal distribution with a mean of 3 centimeter and a standard deviation of 0.15 centimeter. The specification called for cork with diameter between 2.92 and 3.17 centimeter. A cork not meeting the specification is considered defective. A cork that is too small leaks and causes the wine to deteriorate. A cork that is too large doesn't fit the bottle. What proportion of cork produced by the machine are defective? All right. So we have this wine. Let's see if I can draw this wine. No, that's horrible. Cool. All right, so we have this wine. So what we want to do, we have this cork. All right. So we have this wine. So for the wine, what they want to do, they want to have a cork. So for this one, it's important that the cork meet the particular specification of how big it should be. Because say if the cork is too small, when it try corking it, essentially you're gonna fall into the wine bottle. Cool. But then you can also have one that is too big that doesn't fit into the cork. So you go like, okay, like if it doesn't fit, it's not gonna be able to block it. So what we want to do, we want all of the cork to be a particular size, so that way it could cork the bottle. So what's considered to be a good diameter for the cork? All right, so between 2.92 and 3.17. Cool, good. So we get, so we get 2.92, and we get 3.17. All right. Everybody happy or everybody good on how do we get the 2.92 and the 3.17? All right. So for all the cork that fall in between 2.92 and 3.17, are they defective or are they not defective? Cool. So we'll say not defective. All right. So do I want to find the probability of the grain? Well, let's read the question again. Okay, if you look at the question, it says, I love the very capitalized no. It says, what proportion of cork produced by the machine are defective? If I were to find the probability of the grain, that's the probability that's not defective, which is, I don't want that because that means that's the probability that the cork is actually good. I want the probability that the cork is defective. So essentially what I want this probability over here, and I also want this probability over here. Cool, perfect, Raimundo. Yeah, so if you look at this one, what we want to do, we want to go back to chapter 5 and we want to use a complementary rule because it's going to be easier to find the probability of the grain. So we're going to find the probability that the cork is not defective, and then you do 1 minus that, and that's going to give us the probability that the cork is defective. So everybody good on why we're going to find the probability of the grain right now? Okay, so let's go ahead and find the probability of the grain. So let's go second, vars. We do normal CDF. All right, so my lower bound is 2.92 with that neon green. Very hard to see. Then we could do the upper, which is 3.17. Then we could do the mean. The mean, if you remember, was 3. My sigma for this one was 0.15. And then we could go to paste, go to enter, and we get that. So you get the answer to be 0.5746. All right. So remember, this is not my answer. This is the probability that the thing is defective. Or sorry, not defective. But I want the probability that it is defective. So you do 1 minus, your calculator has a neat trick that if you press second, and if you press the negative symbol right below 3, it will get the previous answer and you put it there, and then you just go enter, and you get your answer. So probability of defective is equal to 0.4254. All right. So your final answer should be 0.4254 because that's the probability that the machine or the cork is defective. So let me go ahead and share what I put onto mine. So there you go. All right. Any question in regard to that last problem? So just remember for these problems, you kind of want to read them thoroughly so that way you kind of just don't jump into it. Because some of you just want to jump into the problem and you don't read exactly what is it actually asking for. So just how you kind of read the problem, make sure that you understand what is it asking for. Once you understand what is it asking for, then continue on with the problem and get that answer. I'm all over the place. No, you don't divide it because essentially you don't know if both of the number are equally distributed. Because if you look at this and this, they're not symmetric. Like this left side is not the same side as the right side, so you want to divide. All right. How do we feel about the application of normal distribution when we have a word problem? Do we feel okay with it? Do we feel meh about it? All right. Yeah, if you want, you can also do normal distribution from both sides, and that should give you the same answer. Let's see. It should give you the same answer. All right. All right. So what we did right now, we're getting an X value, and we were converting to a percent. That's like the simplest I could put it. We got an X value, and we got the probability of that X value occurring. So you know what we're going to do next. We're going to do the opposite of that. We're going to start off with a percent and convert it into an X value. So we're kind of going to just do the opposite. So instead of knowing the X value, what we do know, we know the probability, and we want to find what the X value that corresponds to that probability. So kind of like think about it like if you ever gone to the doctor, they tell you like, okay, you're in like the 90th percentile or the 20th percentile or the 10th percentile. So what we're gonna do, we're gonna calculate like how do they calculate like how tall somebody had to be like in the top 10 percentile, or how tall did somebody have to be in the bottom 10 percentile. So what we're gonna do, we're gonna be calculating that. So we're gonna start off with a percent, and what we're gonna do, we're gonna end up with an actual X value that corresponds to that percentage. So for this one, we're gonna go back and we're gonna use inverse norm. So if you were okay on using inverse norm, this is gonna be good for you. If you were kind of shaky with inverse norm, well, you get time to practice now a little bit more on it now. All right. So let's get started. So the first thing we're gonna need a formula. So to find the formula, so in this case, what we're doing, we want to find X. So we have our Z-score formula. So what we have to go ahead and do is use our Z-score formula and just solve for X. So to be able to solve for X, so we're gonna do this. So first thing we're gonna do, we're gonna get rid of sigma. So to get rid of sigma, we multiply the right side and the left side by sigma. So sigma divided by sigma cancel out and become 1. If I do sigma times z, well, you get sigma times z. So now I'm left with z times sigma is equal to x minus mu. How can I get rid of the mu? Or how can I get rid of the negative mu? Cool, so we add mu to both sides. So this will cancel this, and we end up with x is equal to mu plus z times sigma. All right, so if you have the note, I already put that formula here for you. So for this one, you really don't need to know how to get the z-score and convert it into x is equal to mu plus z divided by times sigma, because you already have the formula. So this should probably be one of the formula that you want to write down. All right. So up next, let's go over the instruction on how to find the x value. So the first one is you draw. So if you're wondering where am I reading from, is here. So it says draw a normal curve and shade the area that corresponds to the proportion, probability, or percentile. Step 2, use inverse norm to find the z-score that corresponds to the shaded area. Step 3, obtain the normal value from the formula x is equal to mu plus z times sigma. And then you'll find your x value. So those are the 3 steps we're going to take. Any question for those 3 steps? So just remember for this one, we're going to start off with a percent and we're going to end off with an x value. So if you end up with a percentage, you know you did something wrong because you're not supposed to end up with a percentage. You're supposed to start with a percent and end with a x value. So let's go ahead and do this one. So for this one, I did a general problem. So I say mu is equal to 35, sigma is equal to 5. So for part A, it says find the x value for the bottom 25%. So where do you think the bottom 25% will be? So would it be here in the black area? Or would it be here in the red area? So which one looks like the bottom 25%? All right, cool. So we got 2 people who said something. Let's get a little bit more. All right, cool. Yeah, so the black is actually our bottom 25% because the bottom means the lower half. So this is our bottom 25%. So we want to find what this x value is equal to. So we don't know what that x is equal to. So if I look at the x value, if I just had a guess, would you guess that that x value should be below 35 or should it be above 35? All right, good. Yeah. So if you just had a guess, you should think that it should be below 35. Because if you look at the x value, if you look at where is it located, it's located on the left-hand side of 35. So we should be expecting a number that's less than 35. Okay. So we already drew it out. Now we're going to get our z value. So the way we're going to do z value, we're going to do inverse norm. All right, so if I do inverse norm, what's the area to the left of my x? So remember, area is percentage. So what's the percentage to the left? 0.25. So I'm going to do inverse norm of 0.25, and I'm going to see what z value does it give me. All right. So for this z value, should I expect a negative z or should I expect a positive z? Oh, negative. Perfect. So we're all ready to go. So let's go back. Let's do Web2 or TI-84. All right. So we're gonna do second vars We're going to do inverse norm. And we're going to do 0.25. We press enter, enter, enter. We go to paste. We go to enter again. So we get negative 0.67. Here, look at, here, we'll do 3 decimal places. So we'll do negative 0.674. Don't forget about the negative. Everybody good how we got negative 0.674? All right. So I'm going to show you why the negative is very important. So here is our formula that we're going to use for this. So we're going to say x is equal to mu plus z times sigma. Yeah. All right. So for this one, you want to be careful because if you look at the value I got for z-score, I got negative 0.67448. So since I'm rounding off to 3, oops, that's 2. If I'm rounding off to 3 decimal places, you go 0.674 and you look at the 4 right next to it. So since that 4 is less than 5, that means we don't round up this 4. So this 4 right here to the right of the first 4 has to be bigger than 5. Well, it has to be 5 or bigger in order for me to round it up to 0.675. So since we have a 4 right next to it, that's why we didn't round it up. All right. So let's go ahead and do this problem. Let's do some neon pink. So if you look at mean, what's my mean? Oh, 35. If you look at my z-score is negative 0.674. What's my standard deviation? All right, 5. All right, so if you look at it, we have 35 plus a negative 0.674 times 5. So I'm going to go back to the TI-84. We're going to go ahead and work that out. Well, not really. We're going to let the calculator work it out for us. But same thing. So we go 35 plus here. And remember, for this one, since we have a negative value, you want to use the button below the 3. So you want to use the one that says parenthesis, negative, close parenthesis, and you want to put 0.674, and you multiply that by 5. All right, and that's your answer. So we get x is equal to 31.63. So x is equal to 31.63. So in order for somebody to be in the bottom 25%, they either have to get 31.63 or be below that value. So if they get like 30, 29, 20, 15, 10, 5, they will be considered in the bottom 25% because they're below 31.63. And that'll be it for that first problem. So if you look right here, here is my answer. And that's how you'll put it. So if you notice, I started off with a percent and I ended up with an X value. Any question for A? All right, let's do B. So if you look at B, B says find the X value for the top 25%. So pretty much the same thing. The only thing that changes is that I'm wanting the bottom 25%. Now we want the top 25%. So we'll say the top 25% is here. So now by looking at the drawing that I did for part B, for the X value, should we expect the X value that's below 35 or should it be higher than 35? So yeah, so it should be higher than 35 because pretty much since the X is on the right-hand side, it should be higher than 35. So for this one, what do you think our Z-score will be? Cool, yeah. Beat me to the punch, Stephanie. So this Z-score should just be the same Z-score. The only thing that's gonna change, we're gonna make the Z-score positive. Because since we're dealing with the top 25%, it's the same thing as the bottom 25%. The only thing different for the bottom 25%, you get a negative Z-score. But for the top 25%, you're gonna get a positive Z-score. So for this one, we're gonna use Z equal to 0.67, well, 0.674. Any question on where the 0.674 comes from? All right, perfecto. So we're going to say X is equal to 35 plus 0.674 multiplied by 5. I'll get to you in a little bit, Clark. All right, so let's do 35.674 times 5. So I'm going to go over to my TI-84. All right, so let's go ahead and we'll say second. Oh, no second. We'll say 35 plus 0.674 multiplied by 5 is equal to 38.37. All right, so in order for somebody to be in the top 25%, the top 25%, they have to have 38.37 as an X value or something higher than that value. And that will be in the top 25%. All right, but that's it for this part B. Any question for part B? All right, so if you do want to prove that this is 25%, there is a way that you can prove it by using the normal CDF. But what you do have to be careful with, you do have to be careful because you don't want to go from Z-score to X-score. So if you look right now, this is my top 25%. So if I want to do the normal CDF for this, it kind of depends if I want to use the X value or if I want to use a Z-score. So if I want to use the X value, the lower bound will be 38.37. My upper bound will keep going to the right-hand side, so that's 10 to the 10 power. But since I'm using the X-score, what you have to do, you have to make sure that you put the mean of the original data set, which for this one will be 35. And you want to put sigma of 5. And when you work all of this out, it should give you 25%. If you want to do it using the Z-score, in that case scenario, you want to say normal CDF of 0.674, 10 to the 10 power, and that's it. So you do have to just remember, if you're using X value, that means you use the original mean and the original standard deviation. If you're using the Z-score, well, the mean and standard deviation is 0 and 1. All right. Any question on this last problem? Cool. All right, so let's go ahead and let's do a little bit more complicated problem. We're gonna do a word problem. So we're going back to the lifetime of a tire brand. So it says a lifetime of a certain brand of tire is approximately normally distributed with a mean of 42,500 miles with a standard deviation of 3,200 miles. What warranty should the company use if they want 88% of the tire to outlast the warranty. All right. So for this one, let me put 42,500 here. So let's kind of think about this one. So we wanted to outlast the warranty. So we want the tire. So we want the warranty that we give the tire, that 88% of the tire will outlast that warranty. So how should I shade this? Like, should I shade it like this? And that should be 88%? Or let me do it down here. And should I let that be 88%? So which one look more right, A or B? Or here, let me just do a poll. Get this poll going. Launch poll. So which one look more right, A or B? We'll give you 4 more seconds. 2, 1. All right, so let me share it. All right, so if you look at 83% of you chose B, 17% of you chose A. So let's look at this and let's kind of figure out why it should be, well, the correct answer should be B. So the reason why the correct answer should be B, because if you kind of think about it, the company wants to give them the shortest amount of warranty. Because they don't, because if I give them A, that means like 88% of the tire are gonna be below the warranty. So that means the company is gonna have to refund them their money or replace their tire. So we don't want that. We don't want to replace 88% of the tire. We actually want it to look like B. Because if you look at B, 88% of the tire will outlast the warranty, and technically only 12% of the tire are gonna actually need the warranty. So that's why we want it to look more like B. So let me do B over here. All right, so we want it to look like this. So here is our X value. So what we want to do, we want to find out what should be the X value that we set the warranty equal to. So that way we only have that 12% of the tire will actually use that warranty, but the other 88% of the tire should outlast this warranty. So the first thing we're going to go ahead and do, we're going to do inverse norm. So when I do inverse norm, what should I set the probability equal to? Not that. Because remember, the calculator always wants the probability to the left-hand side. If you give it the probability to the right-hand side, you're going to make it find the probability, or you're going to make it find the z-score of the bottom 88%. So you want to give it 0.12. You want to give it this percentage right here. Because this is 12%. Because just remember, the calculator always wants the probability to the left. If you give it to the probability to the right, it's going to think it's the probability to the left, and it will give you the wrong answer. So let's do inverse norm 0.12. So say inverse norm 0.12. So if you do inverse norm 0.12, if we're rounding to 3 decimal places, what do you get? I want to see your rounding off skill. All right. So what do we get when we do inverse normal 0.12? Oh, thank you. So you get negative 1.175. What are you confused about? Yeah, but for this one, we're getting the z value. So that way we're not putting sigma or mean for this one. I'll show you in a little bit how you could do that. Cool. All right, so remember, this is my z value. So we got z is equal to negative 1.175. So we're gonna say x is equal to mu plus z times sigma. So we're gonna say x is equal to mu, which is 42,500, plus z, which is negative 1.175. And we're gonna multiply this by sigma, and sigma is gonna be 3,200. So we get 42,500 plus negative 1.175 times 3,200. So I'm gonna go ahead and just do this in the TI-84. Cool, thanks. So we get 42,500 minus 1.175, correct? Multiply by 3,200. You press enter, and we get that exact answer. So we get 3,740. All right, so you get 38,740, which makes sense. Well, hopefully it makes sense to you. I'll go over in a bit. Let me just switch over to the. All right, so we get 38,740. So for this one, it's telling us if we want the warranty to pretty much get outlasted, so that means that most of the tire or 88% of the tire pretty much outrun the warranty, you should set the warranty at 38,740 because only 12% or roughly 12% of the car would go, well, not the car, sorry, the tire will last under 38,740, but 88% of the tires should last more than that. Oops. Any question on how I did this last one? All right. So there is a way where you could let the calculator do the entire work for you. But if you let the calculator do the entire work for you, you do have to understand that like you always have to give the probability to the left-hand side. Because if you don't give it the probability to the left-hand side, it will give you the complete wrong answer. So let's go ahead and do the TI-84. So if you go to second, you go to bars, let's do inverse norm. So first thing you want to do, you want to put the area. So the area we said was 0.12. But if you look at my calculator, it's asking me for the mean or standard deviation. So if I leave the mean and standard deviation at 0 or 1, it's going to return to me the z-score. But say if I wanted to return the x value to me, what I could do, I could tell it the mean, and I could put what the mean is. So in this problem, the mean was 42,500. If I look at the standard deviation, was 3,200. So by me putting the mean and the standard deviation of the problem, it's not going to give me the z-score anymore. What it is going to give me, it is going to give me the x value now. So if I go to paste, paste. So if you have an older calculator, all you have to do is press 0.12, press comma, then do the mean, and then do the standard deviation, and then press enter. And if you look at it, it'll give you exactly the same answer. It'll give you 38,740.04227. So the reason why I'm giving you like a runoff is because it's using the entire z-score. If it's using the entire z-score, it's not stopping at like 3 decimal places or 4 decimal places. It's using the entire z-score. That way, it's slightly a little bit off. All right, so that's it for that problem. Any question in regard to the last problem? Sweet. All right, let's practice some more. As long as you just round it to the correct decimal value, it should be fine. So for this one, said the resting heart rate for a healthy adult horse average 46 heartbeat per minute with a standard deviation of 8 beat per minute. A horse whose resting heart rate is in the upper 10% of the distribution of heart rate may have a secondary infection or illness that need to be treated. How fast must a healthy horse heart be beating to fall into the at-risk group? So for this one, if you look at it, we want the upper 10%. So we can either say this is the upper 10%, or we could say this is the upper 10%. So which one look right? The red one or the blue one? Blue. Maybe blue. Right. Okay, cool. Well, if you look at it, it says upper 10%. Upper 10% means blue. So the blue are correct. So let's do the mean and let's do sigma. Oops. What's my mean? Oh, 46. What's my standard deviation? Wait. All right, so I'm gonna do it both ways. I'm gonna do it with the formula and I'm gonna do it with the calculator. So let's do inverse. So we're gonna find the z value right now. So if I do inverse norm, I wanna do inverse norm of what percentage? Oh, 0.90. All right, so let's do inverse norm of 0.90. For this one, let's round it out to 2 decimal places. So we get 1.28. Right. Everybody go with 1.28. Sweet. Everybody go with 1.28. So let's do x. So we go x is equal to 46 plus 1.28, all multiplied by 8. So if we do 46 plus 1.28 multiplied by 8, what do we get? You get x is equal to what? So you get 56.24. All right, so we're done with this one. All right, so say if you want to do it all in the calculator. So if we do it all in the calculator, we go inverse norm. What should I put for the probability for if I'm doing it all in the calculator? So what probability should I put for the calculator? Inverse norm of what probability? Oh, there you go, 0.90, and you have to get to 46, and then you put the standard deviation. So let's go ahead and do this. So I'm gonna go ahead and share with you my TI-84. So I go on, I hit second var, and you do inverse norm. So you say 0.90, you say mu is 46, and you say sigma is 8. So if you go here, paste, you go to enter. All right, so if you look at it, you get x is equal to 56.25. All right. But for this one, you do have to be careful because if you were to just say put 0.10 versus putting 0.90, it will give you, instead of giving you the top 10%, it's going to give you the bottom 10%. Remember, it always wants the probability to the left-hand side. So if you are going to be using the calculator, you have to be careful because if you just put the percentage to the right-hand side, it will give you the incorrect answer. You always have to give it the percentage to the left. Like at least if you're doing it with the formula, you could kind of see like, hey, does z-score supposed to be negative or does z-score supposed to be positive? But if you're just doing it with the TI-84 like that, you can't really see that. So we put x is equal to 56.24. And if you look at that answer should make sense because 56.24 is bigger than the mean, which is in the middle. So we're done with that one. Any question for that last one? Wait, all right, so let's do these next. Let me see. Here, we'll do this problem and that should be good enough for practice. So it says consider baby born in the normal range of 37 to 43 week age. Extensive data support the assumption that for a baby born in the United States, birth weight is normally distributed with 7.56 pounds and a standard deviation of 1.06 pounds. All right, so for this one, what's my mean? .56. What's my standard deviation? Wait, 1.06. All right, everybody good on my mean and standard deviation? All right, so let's do part A. So for part A, it says how big does a baby need to be if we want them to be in the top 1%? So we want this baby to be in the top 1% of being a big baby. So we could either put this as our top 1%, or we could say this is our top 1%. So which one looked like the top 1%, the red one or the blue one? Oh yeah, so you want the blue one. So instead of entering 1%, what should I say for inverse norm? Yeah, so you want to do 0.99. So we say inverse norm of 0.99, where you say mean is 7.56, where you say standard deviation is 1.06. And let me actually move this out of the way. All right, so I'm gonna go ahead and do this on my calculator. I want to see what do I get. So we get second bars, inverse norm, 0.99, comma, 7.56, comma, 1.06. All right, so if you do this on your calculator, what do you get for your final answer? All right. Yeah, so you should get 10.026. And that's it for A. Any question in regard to A? All right, let's do B. So for B, it says, how small does a baby need to be if you want them to be in the bottom 4%? So keyword bottom 4%, so we want them to be over here. So if I were to say inverse norm, what should I put for inverse norm? So we put 0.04, comma, what else? Well, remember, for this one, you always want to give the probability to the left-hand side, so you actually just want the 4%. Because the probability of the 4% is on the left side, so you just give it that. So you do 7.56, comma, 1.06. All right. So all you have to do is change it from 0.99 to 0.4. All right. So what do I get for my X value? So you get 5.704. And that's X. Any question on the last problem? All right, so you kind of look at the format of the problem because like for some of you, you're having trouble with like reading the problem and just like understanding what's given to us or what is it asking us to do. So if you look at this one, they're telling us here is the percentage. So we don't want to find the percentage. We want to find what is the X value that corresponds to this percentage. If you look at the last problem or the last section that we did, for that one, they will tell us this is the X value and find the percentage for this one. Also, like the other thing you want to notice for these type of problems, all of the problem always mentioned that we have a normal distribution. Kind of, if you remember when we did the empirical rule, the only way that we could utilize the empirical rule if we know our data set is normally distributed. The same thing goes for this data set. We can only find the probability using the normal CDF if I know our data set is normally distributed. If our data set is not normally distributed, technically there's other way that we can find the probability. But for all of this chapter 6, all of chapter 7, all of chapter 8, our distribution is always going to be normally distributed. All right. Everybody good for this last round? All right, so I'm gonna leave the aircraft cabin for you to practice if you want to practice on it. Wait. All right, so up next we're gonna do assessing normality. So for this one, we're not gonna do any math. For this one, what essentially we're gonna let the calculator do all the work for us. So what I'm gonna show you some example of normality plots. So for normality plot or normal probability plots, but this is what we're doing. For normal probability plot is the other way that we can see if our data set is normal or approximately normal. So usually if we have a histogram, for the histogram, we kind of want it to resemble this shape. Because if the histogram have that shape, that's kind of telling us if our data set will be normal. So what the normality plot or the normal probability plot is, on the x, this is going to be your x-axis, and for the y, going to be the expected z-score. So by using the x and the expected z-score, we're going to be able to see if we have a normality plot. So usually if you see a straight line, we're going to say our data set is approximately normal. But if we see any curvature in the line, we're going to say it's not approximately normal. So what I have in this lecture notes, on the left side, we have the histogram of the data set. On the right side, we have the normal probability plot. So if I'm looking at this histogram, does it look normal? No, so we're gonna say not normal. What about this normality plot? So does this normal probability plot, does it look like a straight line? Yeah, because if you look at it, it does kind of a good job here, but it kind of loses it at the end of it and at the beginning of it. So for this one, we're gonna say not normal. And the reason why it's not normal because essentially it doesn't look like a straight line. All right, let's look at another example. How does a histogram look? So what can I say about this histogram? Can I say it's normal, skew to the left? Yeah. So this is skew right. So what do you know about the normal probability plot? Does it look like a straight line? No, because if you look right here, it doesn't look like a straight line. Because if you look at over here, and this is called because of this portion right here. Because since it's right skew, it's gonna have curvature. So that's why for this one, we're gonna say not normal. All right, let's look at other example. What about this next example? What does the histogram look like? Perfect. So we say skew. All right. What about our normal probability plot? Does that look linear? No. So if you do a line, that's your line. So it's messing up here, messing up over here. So we'll say not normal. All right. All right. So if you look at this one again is skew right. This one, not normal. Doesn't look like a straight line. All right. What about this last one? How does the histogram look? Cool. The histogram looked normal. What about now the normal probability plot? Does that look like a line? Yes. So since it looked like a line, now we could say it's normal. So the normality plot is a different tool that we could use. So in case you don't want to do a histogram, in case you want to do the normality plot, if the normal probability plot give you a straight line, then you know that it is going to be normal. If it doesn't give you a straight line, then you know it's not going to be normal. So let me see, should have enough time. All right, so here are the instructions on how to do a normal probability plot, but I'll just walk you through it. So let's do this example. So we have this data set, and what I want to do, I want to look at this data set and see, based off the normal probability plot, do we have a straight line? And if the normal probability plot give me a straight line, that means that we could say it's approximately normal. So I'm going to show you how to do this in the calculator. Should have enough time. All right. The first thing you want to do, turn on the calculator, press the stats button, press edit, and let's enter our number. So if I enter my number is 678, for this one, the order doesn't matter how you enter it. You could enter however you want. The order is not going to affect it. Eight. All right. So you want to enter all of the data set in. Once you enter all of the data set in, what you want to do, here, let me do this. Let me do my spotlight. So you want to hit the second button, and you want to hit right here where it says y equal. So one thing you want to make sure that all of these plots are off. The only one you want on is the first one. Any questions so far how to get here? All right, so I'm going to select the first one. So the first thing you want to do, you want to make sure is on. So if your calculator, if the off is kind of like blinky, you want to press enter on. So that way you know it's on. So then what you want to do, you want to press down. And what you want to do, you want to go all the way to the last one. So to get all the way to the last one, you hit the right arrow. So you go 1, 2, 3, 4, 5, and you press enter. Everybody good that you press enter on this one? So then if you go down, it should say data list. So data list is where you put the data. So I put my data in L1. And for the data axis, for the data axis, you want to make sure it's on X. Everybody good on what to punch into these screens? All right, for some of you, you might get an error message because some of you might have stuff into Y equal, or you might have some other drawing that's interfering with this drawing. So if you do get that error, I'll try to help you out. But if you do get that error, if I don't help you out, try going to my office hours so that way I can help you out. So the next thing you want to do, you want to hit the graph button. So you hit graph. So if you didn't get an error message, you might get this picture. So you're getting this picture because pretty much you're not zooming in the right direction. So kind of think about it if you're looking left, but all of the cool things are happening on the right hand side. So what we have to do is to tell our calculator to look in the right direction. To tell the calculator to look in the right direction, you press zoom. And what you want to do, you want to scroll down, or you can hit the number 9. So if you look right here, it says zoom stats. So now your calculator is going to be looking in the right direction. Right. Any question in regard to this drawing? Perfect, good. All right, so now you know how to do a probability plot. So this is how you do it. You don't have to worry how to do it by hand. By hand, it takes too long and you're not gonna have enough time to do on the test. So you have to know for the probability plot, as long as it looks like a straight line, you're gonna say it's approximately normal. If you look at this dot right here, this dot is kind of suspicious because it kind of makes it look a little bit curvy, especially if you look at the dot at the back end. These kind of make it look a little bit curvy too. So for this one, we'll probably say that it's not normal. Right. Any question in regard to this last problem? All right. So let me go back to my notes. All right. So if you look right here, on the left-hand side, did the histogram for you. So if you look at this histogram, you could kind of see it's skewed, not right this time, but it's skewed left. So if you look at this one, that's why we're gonna say not normal because of this dot and these dots over here. Like in order for it to be considered normal, you kind of have to see a straight line. But that's it for the last problem. Any question in regard to the last one? All right, so I'm gonna leave you some homework. So your homework is just to enter this into L1. So from here to tomorrow, all I want you to do is enter this list into L1 because it will make it easier because I don't want you to enter all of these data sets tomorrow. So it'll take you like, I don't know, 5 minutes to enter it maybe. So if you can, just enter this list into L1 for me. So that way for tomorrow, we don't have to worry about having to enter that into L1. Any question in regard to that? Oh, yeah. And if you need help on how to clear your L1, I'll show you right now. So all you have to do is hit the stats button, go to edit. If you hit the up arrow, you want to make sure L1 is selected. You press clear and you press enter. And that's how you clear L1 data set. All right. Here, I'm going to show you this meme that one of the students did for other class that I'm teaching. It's about me asking questions. Sounded pretty funny. Yeah. Apparently that's the effect I have when I ask questions. All right. So that's pretty much it for today. So if you do have any questions, remember I do have office hour from 6:45 to 7:15. But if you need a little bit more time, what you could do, just email me letting me know, hey, can I meet during this time? So that way I could help you out. But this is kind of like going to be the crunch time because from chapter 7 on up, everything's going to start kind of looking the same. So you do kind of want to start making some notes on saying like, okay, what chapter 7.1 is about, what 7.2, 7.3, so on and so forth. So do start making some notes. If you have any questions, go to my office hour so that I can help you out. But do try to get some help. I'm going to show you how to do that tomorrow. So I'll show you tomorrow how to construct the histogram, not the historian, and I'll show you how to do the probability plot. But all I want you to do is just enter the data set into L1. So that way for tomorrow, you're not spending like 5 minutes entering it into L1. All right, class. Any other questions before I close out this meeting? Cool. All right, so that's pretty much it for today. I'll see everybody tomorrow. And I'm gonna upload, well, I'm not gonna upload, but I'm gonna post the solution for your exam. So that way, if you already wanna get started on the test correction, you could get started on the test correction. The test correction, I'll make it due on Wednesday, so that way you can have a week. But also kind of remember, you don't wanna spend all the way till Wednesday working on this because if you do, pretty much you're gonna have a bunch of other stuff that kind of get piled on. So if I were you, try finishing out the test correction by this weekend. So that way you can focus on other stuff like chapter 7, chapter 8, because we are getting into the tougher chapter. All right. So that's it for me. I'll see everybody tomorrow. Have a good night.